Defining the problem means state the variables. So please take out this paper's end somewhere from the net. This is June 2022. Paper is 52. I just quickly go through the main slogan, that is think, plan, and organize a practical. Marks allocation, defining the problem, methods of data collection, which means diagram, method of analysis, 3 marks, additional detail which are called smart points. It includes safety precautions also. Two parallel cylindrical conductors. Remember, in a design question, you have to think. You have to think and you have to plan. Then once you get a book, let me know. Then I can practice the analysis question with you. As soon as you get it, please let me know. Maybe you can try to get it tomorrow. Two parallel cylindrical conductors each have a small cross-sectional area A. A thin metal bar connected the two conductors as shown. Remember when you are doing, when you are doing a paper 5 question, remember when you are doing a paper 5 question, you have to be careful. You have to remember that you have to read it at least twice or thrice. It's a 15-mark question. If you take a wrong approach, then everything is gone. So please read the question. I'm just coming, read this part. The metal bar, if you have read this first part, as I mentioned, you have to be very careful in reading the question. Two parallel cylindrical conductors each have a small cross-sectional area A. A thin metal bar connects the two conductors as shown. The metal bar has a square cross-section with the sides of length y. For each conductor, the distance between its end C and the center of the metal bar is L. The distance between the centers of the conductor is x. Look at this x. The NC are connected to a power supply and the current in the conductor is measured. Read it. It is suggested that I is related to L by the relationship. This is the formula, and a unique type of formula is given in every question. This is not a memory formula. E is the electromotive force, EMF of the power supply. P and Q are constants. Plan a laboratory experiment to test the relation between I and L. Draw a diagram. Explain how the results could be used to determine values for P and Q. Now read this again. So if you have read the first part, as I mentioned in this topic, the main important thing, how you judge the question. If you judge it carefully, then you can score it well. So the parallel cylindrical conductors each have a small cross-sectional area. A thin metal bar connects the two conductors as shown. This is the type of circuit. He says then metal bar has a square cross section for each conductor. The distance between its NC and the center of the metal bar is L. The distance between the centers of the conductor is X. Now NC are connected to a power supply. Look at the NC. NC is on the left side. Okay. If you connect it with the power supply, you will you will allow the current. If you people have identified it, it's a current. Current is in the wire. So what are the variables?
The independent variable would be L.
Right? But why he's talking about, is this wire going to move? Or what's going to happen actually? What he's trying to do? the NC. So when he gives the power and the current I in the conductor is measured. Okay, we measure the current. It is suggested that I is related to L by the relationship this. The L, look at this L. So what he is changing and what he actually what he is actually trying to do. You are allowing the current, but how L will change?
So you change the length L to measure to see the different measurements for current.
Because remember, there's a topic called electromagnetism. Then your input is also needed. Electromagnetism, when current passes through a wire, it produces a magnetic field. This is a case of electromagnetism. In your plan, you should include the procedure. Now, I have taught you this important feature that do take 10 minutes and do understand the question. Variable. Now, give us side heading variable. This is defining the problem, 2 marks. So copy this. L is the independent variable. I is the dependent variable. We will change L, the length. And when we change length, it is producing a magnetic field. It will change the resistance. Look at this. When you increase the length, the current will change because the resistance of a conductor is directly proportional to L. Furthermore, the two cylindrical conductors will be opposing each other because they are having currents in opposite direction. Now copy down the variables. I want to keep E constant. E is the EMF. Procedure. This is also called method of data collection. So give the heading procedure, a side heading. And now I'm showing my thinking process. I'm going to use a ruler to measure L and X. Again, look at the diagram. Keep on looking the diagram. L is the length, which I'm going to change. X is the length, which I'm not going to change. I will use a meter rule to measure capital L and X. L and X need to be measured precisely. Here, I'm showing how I can measure the total X. I will measure the small a. If you look at the screen, I will measure this a, and I will add the diameter. This is the diameter. I will measure the diameter and add them in the value of a. Can you tell me how I can find the diameter?
You can use a micrometer and then
Which
half.
micrometer, right? This is the diameter. Vernier caliper can also be used. Perfect. Vernier caliper can also be used. It's a possibility. Definitely micrometer or vernier caliper, both can be used. Look at this diagram. Y upon 2. I will measure the total length and I will half it and add it in this equation. So it will be L. B. How we measure L? We first measure B, then we measure Y and then divided by 2. Y can be measured by vernier caliper or micrometer. Use a micrometer to measure Y. Area can be found by pi d square upon 4. Determination of EMF. This is my thinking process. How I can measure EMF? I can use a voltmeter with a power supply, and this is a concept of use. Some cases, the voltmeter is built in. and it is called a complete power supply. So I can read it for the EMF. This is my thinking process. How I am thinking, let me show you again. Actually, the main thing is this formula. I am thinking according to this formula in the paper, how you will make your thinking process. Like here, you have to think for E, for I, for L, for A, for X, for Y. Why you're not thinking for P and Q? Because you have to find P and Q. So that this equation is the thinking process. Now, this is the idea. This is how we make the connection. This is how we make the connection. These are the crocodile clips. I have attached them here and I have shown a voltmeter on the power supply. I have shown an ammeter and I have attached wooden blocks so that it gives us support and I can measure the center to center separation. I have placed the wooden block so that the horizontal rods do not move. Diagram is the most important part and your presentation actually comes here. Diagram is very important, and when you solve this question, always remember to draw a neat workable diagram. So you have to copy this screen. You have to copy this screen neatly. If you have the book, you should copy in the space provided in the question. Let me know once you people have copied it. Control of variables. Control of variable is an extended topic. It is not necessary to include it, but it's a good gesture if you show this, that how you control the variables. Now, remember that after making the diagram, you have to write down a concise procedure. You have to write down a concise procedure, and then you have to mention control of variable. So in the actual paper, there is a special space for the diagram, and there are lines for the answer where you are making these headings, where you are making these headings. Now, right under it, arrange the operators as shown. Arrange the operators as shown. Now, our thinking process now involves here, use a meter rule to measure L and X. Write in a continuous paragraph, use a meter rule use meter rule to measure L and X. Here you have to tell the examiner how you will measure the X. For that, you will take the two radii, make them the diameter, and use the formula X is equal to A plus dia. Now, if your diagram is quite big, quite clear, you can show this working on the diagram. I'm showing it separately here. You have to show this on your diagram. update your diagram, add it there, this working A plus dia, and show this there. You have to tell me once you have copied it. Yes, have you copied it, Afra? Then also, are you doing something or are you there? Okay, you are there, but you don't have the paper. So, inshallah, when you get it, you will start working on that. Now, my thinking process will help me. My thinking process have to be connected here. Now, how I measure L? Actually, L is going on the rod, in the mid of the rod. So first you measure B, then you measure Y upon 2 and find L. Please copy this also on your main diagram. This one, main diagram. Let me know once you people have updated it. Now, area can be found using the micrometer or vernier caliper. So right under it, again, I'm looking back to my formula. Look at this formula, big one. This cross-sectional area. So right in the continuous paragraph, use vernier caliper to find the diameter. Use vernier caliper to find the diameter then use the formula A is equal to pi d square upon 4. Then A is equal to, then use A is equal to pi d square upon 4. We are talking about this area. use a power supply, use a power supply with a voltage display, use a power supply use a power supply use a power supply to with display measure the EMF measure the EMF So we have gathered many features. Now, right under it, now switch on the circuit. I forgot to make a switch here. So please make a switch. Switch on the circuit. Switch on the circuit. Switch on the circuit. Note the ammeter and voltmeter readings. Switch on the circuit. Note the voltmeter and ammeter readings. Note the voltmeter and ammeter readings. Now switch off the circuit. Now switch off the circuit. Allow it to cool. Allow it to cool. Now alter the length L by moving the metal bar. Now alter the L. Alter L by moving the metal bar. Alter the L by moving the metal bar. Repeat the trial. Repeat the trial. Repeat the trial for different values of L. Repeat the trial for different values of L. Repeat the trial for different values of L and record the values in a table. Now give the heading and record the values in a table. Now give the heading control of variables and copy this. Now give the heading analysis. Again, analysis is something which gives a free marks, but you have to remember what variables you had taken. According to the variables you have taken, you have to decide for the equation. It's a game of y is equal to mx plus c. Now give the heading, a side heading, analysis, and copy this. Method of analysis. There are 3 marks for that. You have to quickly copy this. Let me know once you have copied it. Let me know once you have copied it. This is a linear law. I'm rearranging it in y is equal to mx plus c. Now, looking at the equation, I can tell examiner what is the y, what is the x, what is the gradient, what is the y-intercept. Draw a graph of 1 upon I against L. As C is not 0, it is a relationship which is valid if it's a straight line, but not passing through origin. You have to copy this quickly. Let me know if you have copied it. Now, quickly give the heading precautions. There are two types of precaution. No need to write accuracy and safety. Just give the heading precautions. Number one, look at this apparatus. Whenever you are writing precautions, look at the diagram. So you use number one, make bulleting. First bullet, use electrical insulation gloves. Use electrical insulation gloves. Next bullet, make sure the contacts are tight. Make sure the contacts are tight. Wooden block, next bullet, wooden blocks are there to hold the rods. Next bullet, take multiple readings and take an average. Take multiple readings and take an average. So this question is completed and we are stopping here and we will inshallah continue in our next class. Allah Hafiz.